super excited to have Harry and Ben here. We've been working together for a little over a year, and they are, I think, just a really dynamic, interesting, innovative team. And so we'll get into not only what they're building, but how they work together. And of course, as always, open it up to all of your questions. So just to get through their formal bio. So Harry and Ben are the co-founders of Gensyn, which is building a decentralized machine learning compute protocol that acts as the rails upon which AI models can train on any compute device in the world. And we'll talk a lot more about what that means. Harry previously led the data research team at an applied machine learning startup and holds a postgraduate degree from Brown with a focus on econometrics. Ben previously co-founded data privacy and sovereignty startup and holds a PhD in neural architecture search for deep learning and computer vision. So let's maybe start with, how did you guys meet each other and decide to start Gensyn together?
Yeah, so it started on Entrepreneur First, which is maybe a dirty word here because it's another accelerator. But we met in 2020, and from my side, I'd been leading that data research team for approximately 3 years, solving kind of large geospatial data problems where we were predicting disaster events for insurance companies. Around the time we were hemorrhaging money on compute to train these models. And two, it was just after GPT-2 had just been released. So you could kind of see the sands shifting beneath our feet. You know, the model parameter density was increasing, the costs were spiraling, and it felt like a good time to kind of, start a company. It turned out to be the jaws of COVID, which was an interesting point. So Ben and I met on Entrepreneur First, which for anyone who doesn't know, it's basically billed as sort of a combination of Shark Tank meets Love Island. So you join and you, as a person with the idea of finding a co-founder, and they kind of pre-select people to join the accelerator. And yeah, that's where I met Ben.
Yeah, and I was coming out of my previous startup, which I'd been running for a couple of years, as Jason said, in the data privacy space. So we were a very ideological startup focused on giving people control of their data. It was we started around when GDPR kicked off, and then learned that building a startup based on regulation like that is a very tricky thing to do, and puts you at the whims of regulators, which is tough. And we also just generally kind of made a lot of the startup mistakes. So I kind of speed ran the early startup journey, realizing that when you pitch investors and they give you information, that's through a certain lens. And we made a lot of decisions based on that now I kind of learned that actually potentially those decisions were taking us down a path that wasn't optimal for the business, which ultimately led to having multiple products in a B2B space for managing GDPR administration, and nothing to do with the ideological people taking back control of their data, which as a founder is a horrible position to be in, because then you think, well, I could grow this product that I don't really care about, but I can't actually achieve that kind of vision I had anymore. So I took the difficult decision at that point to shut that startup down. We had funding, we had offers to kind of have more funding, but it wasn't leading in the direction I wanted. And Entrepreneur First represented a way of basically resetting, going back to kind of what I knew, which was machine learning. I'd finished my PhD in deep learning a year before, and basically look at the space of possibilities with somebody new and figure out what I could do. And then that's exactly what happened with Harry. So joined Entrepreneur First, like Harry said, got there on the first day. They said, okay, welcome to the in-person part of Entrepreneur First, and also say goodbye to it because you're all going to go home and not see each other again in person. And then we did that. And I think we skipped a lot of the sort of Love Island aspect because we teamed up very early, and then just essentially worked together from the start in probably 14-hour Zoom calls from our respective flats in London, periodically getting walks along the Thames, but not as often as we'd have liked.
Yeah, and I'd say the kind of three things which we unified over in those early days were, one, we wanted to build something enormous in the machine learning infrastructure space. That's kind of always been consistent. The second one was we had both just finished reading Edward Snowden's autobiography, and we felt very aligned with some of the cypherpunk principles in that. This, similar to like Ben's previous startup, but also these ideas around like the ongoing fights for end-to-end encryption, etc. Bonded over kind of our support of like the Tor Foundation, stuff like that. And then thirdly and finally, being from the north of the UK, both of us, we just had a similar sense of humor. And I think like the single like largest like piece of advice I would like give like any new founders, like if you can't laugh with your co-founder, it's like lights out eventually because the situation, like I think the biggest one for us was when like Signature Bank collapsed like last year and we lost all our money for like 24 hours. And if you can't like find like humor in it, it's just not great.
It breaks the tough discussions as well, because like you, as a founding team, you are going to have discussions that you both feel really passionate about, and if you're not able to kind of like just like collectively look in the mirror and be like, okay, yeah, we're going to have this really passionate discussion, but at the same time, like there's a bit of humor in it. Like we're not going to take it fully to heart and end up kind of taking something super personally. So I think there's a lot of discussions we'll get into, and we'll probably talk about this a bit later, but Harry and I do have pretty robust discussions. We're like quite proud of that. It's a good way of working in our opinion, but there'll be moments in those discussions where we'll both just like burst out laughing, because like if you don't, you just end up getting way too attached. And I think that it's quite nice to like when that moment happens, basically, because it just cuts any like tension that might have been there if there was tension, basically.
Amazing. So talk a little bit. I mean, so what is Gensyn? Why does it need to exist? What's it going to be tomorrow? And then what do you think it turns into 2, 3, 5 years from now?
Yeah, so there's probably two ways of viewing, or like reasonably simply two ways of viewing Gensyn. One is much more immediate, and it's a kind of backward-looking way of saying that the market for machine learning compute, so the devices that actually do the computations behind machine learning, is a highly constrained market. Access to chips is just limited right now, and it leads to incumbents, people like AWS, Google Cloud, Azure, having a stranglehold on top of that market and being able to charge essentially whatever they want. And then it stifles innovation because you get all these startups who think, hey, there's something really cool I could do in machine learning, but I can't get access to the chips to do it. And it's a problem we'd both felt really strongly. So I felt it in my PhD. I could only buy 4 GPUs and put them under my desk. But I was competing with like Google Research, who would have thousands of them and run these huge tasks. I knew exactly how to do those tasks, but I couldn't access the compute to be able to publish papers in it, which was frustrating. But also when you kind of zoom out on the world, you think, well, there must be other people in that position and they can't do these cool new things. It's only one entity who can, and that's not a good state of the world. Harry had experienced it with in the kind of industrial context, actually accessing, like being able to pay for the compute, but not being able to get it. I couldn't pay for it. Harry couldn't even get it with the money there in the funding that they had. So it was clearly a constrained problem that went just beyond kind of cost. We solved that problem by just creating a completely open market over it. So we build open source software that anyone with a GPU or TPU can run, and they can join this global network where they can rent out access to that device. It removes those kind of limitations of, if I want to become a compute provider, I have to basically become AWS in order to do it, and says, let's replace all of the kind of human world things that AWS has to do, account management, infrastructure, things like that, with technology, and crucially replace the trust part. So with AWS, you have this kind of trusted relationship. You establish legal contracts with them with SLAs. That's a very expensive thing to do in general for the world. It requires people to do things. Gensyn replaces all of that with tech. So cryptographic, probabilistic, game theoretic proofs that the task that you've sent to a device has actually been done correctly. And then you can have settlement of the relationship of supplier and demand side participant without ever having a human do anything in that transaction. That moves us on to the kind of forward-looking second way of viewing Gensyn, which is we think the machine learning world is moving towards much more automation. Models themselves will be doing those interactions, not people. And when models do those interactions, they can't rely on a person or a physical legal contract or a court system. They have to rely on technology and computations themselves to settle the transactions. So we view the world relying more and more and more heavily on machine learning technology, essentially, as it is now with imperative code, being replaced with models in basically every aspect. But as that happens, those models need agency in the world. They need to be able to interact. And the first thing they need agency over is their own resources. And compute is the most constrained of those resources. And we unlock that with this technology. I don't know if you just add, modify anything on that, Harry.
Yeah, I could kind of present it just in like 3 priors that we have, which inform Gensyn. The first is that the machine-to-machine economy, which is going to emerge in the next 10 years, will eclipse the kind of human economy. So just agents working with each other, transacting value with each other. we have a kind of human to machine economy emerging just now, but the machine to machine one will eclipse everything. The second point is the notion of kind of computational liberty, like this idea that, you know, in the next, say, 5 years, when we have consumer brain machine interfaces, which are non-invasive, and, you know, you're, for the first time ever, your kind of biological neurons are interfacing with artificial neurons in a way which, you know, you don't really have much control over because it could be closed source. It's very important that people have the ability to train models which go in those devices and kind of read your thoughts and allow you to interpret the world differently in a way which is aligned with your values. And you don't get that if someone has the ability to turn off a kill switch somewhere. I mean, the third and final point is just this notion that, you know, the substrate on which machines are going to train and kind of exist, it has to just be permissionless. It can't have these kind of real world tie-ins, which is why many of the verification systems and many of the kind of Web 2 approaches so far don't work for this new economy with machines. They require a human in the loop, or they require some type of trust, which fails at scale. And the majority of our research to date has been on solving that final point around trust, verification.
And Harry, you have a personal interest in censorship resistance. Talk a little bit about that, where it came from, and I think you partially answered this, but how that ties into what you're building with Gensyn.
Yeah, I think this is like, you know, the trigger warning quite like philosophical, but like if you care about the idea of liberty, so the idea that the rights kind of start with the individual, and, you know, you give away rights willingly to other people, you're probably on, at least in the West, and at least in the last kind of few centuries, you're in the majority. What we've kind of had with the internet is a speed run of kind of capture, where large entities and governments have managed to lock down entire swathes of this kind of digital universe that we frankly spend most of our time in now. So, you know, the ability to kind of control dissent, to sort of manufacture, you know, consent with, you know, advertising, and overall just the kind of oligopolistic control of certain kind of cloud institutions have made it very, very hard to really look at the internet today and view it as truly free. There's been pushback against that. It happened kind of in the late 90s with the wars around cryptography and this idea that, you know, the US government was trying to make elliptic curve cryptography a munition. So you'd be like a terrorist if you were using like HTTPS. And then, you know, in the kind of late 2000s with Satoshi, when they released Bitcoin, they kind of gave people their money back in a way. We think that right now we're at another kind of critical juncture where it happened with encryption, it happened with money. The next big one is intelligence, and the ability to kind of freely train models and to freely kind of, you know, interact with open source models is coming under threat. You see it in, you know, the US with various executive orders from the state level and the federal level. You see it in Europe with the AI Act, and, you know, there's some good stuff in those bills for sure. They kind of provide clarity. They you know, help, you know, businesses kind of navigate issues with consumers, but ultimately they're also regulatory capture, and they're bankrolled by the kind of usual suspects. That doesn't work if we want a kind of open world where liberty sits at the center of everything. And that's why when we're building Gensyn, it has kind of two key qualities which relate to this. One, it's permissionless, so anyone can access it. There's no kind of KYC at the protocol level, just like HTTPS. And two, it's built with the idea that the world won't be a kind of one universal model, which is sitting in kind of California somewhere, owned by OpenAI and kind of lobotomized in a way which is, you know, suitable for the people who've created it. It will be a tapestry of lots of decentralized models around the world, which are all open source and all reflect the values and belief systems of the people who created them. So that's kind of how it interfaces, yeah.
There's an interesting pattern match you can do there in the past, where one area where it did work particularly well is the outcome of the protocol wars of the late 20th century for the internet. So like the TCP/IP stack does effectively, as long as other things aren't kind of allowed to capture it, provide that equality of everyone. Like the way that our devices talk to each other is a standardized way which is completely open to people to use. It's not owned by a certain company. But if you look at how that developed, we developed that standard and we allowed these devices to communicate, but then there's certain things we didn't bake into that standard. And one of those crucial things is the accounting for the resources used. So within communication, it's a bit different from computation, but you're still using bandwidth every time devices talk to each other. And that accounting of bandwidth was taken by telecoms companies, and those those telecoms companies then run with that, and they capture the kind of monetization of that core resource. One way we see Gensyn is building the TCP/IP stack, but for that next kind of revolution, like Harry mentioned, for intelligence rather than communication. But learning from the past, we say, hey, that resource accounting should be in the open protocol itself. We couldn't do that before. We didn't have the ability to have like open kind of financial systems before. Now we do. It's a kind of step up in our ability to build a open standard that won't be captured by somebody else. There'll be other areas where we'll have to battle on it. Inevitably, there'll be unknown unknowns, but we can do a better job now with new technology, which is cryptocurrency and blockchain, essentially. So it's kind of stepping up our ability to build fully open standards that allow devices to communicate and then eventually allow machines to communicate and create an entire economy.
And talk a little bit about, I mean, you very explicitly chose to focus first on training rather than inference. And I think conventional wisdom is that inference is just a much bigger market, right? Because it needs to be done every time someone wants output for a model. But talk about why you chose to go that direction.
I think the kind of core reasoning was threefold. So the first part was typically training's compute constrained as opposed to latency or bandwidth constrained. So if you're building a decentralized system, it makes sense to, trade in favor of compute. It's not, strictly true. Like you can have decentralized inference protocols that make sense, but it's just more hand in glove on the training side. The second kind of more consequential point is when you get back to kind of philosophical reasoning that we had, the training accounts for so much more of the perception. Like it's the way the model's interpreting the world is determined by the training. The idea that, you offload all the pre-training to a few companies just felt crazy to us. So it was starting there. And thirdly, and this is probably like maybe even more relevant, it was a problem that we had. So like we came from this world of training models. It was why it was costing so much. And I think, inference has definitely stepped up enormously recently. But we felt the problems ourselves. So back when we kind of co-founded in 2020 and kind of before, ChatGPT and everyone's kind of talking about it and the video stock was going through the roof, we were like, yeah, well, training is a problem. I don't know if you would.
Yeah, I'd maybe offer a different lens in the same way as the like backwards and forwards looking kind of two-piece thing again. Like in the backwards looking way, I think training is just an easier problem to bootstrap a network on. Because like Harry said, training is asynchronous, it's heavily compute dependent. It's a better place to start in terms of providing value to somebody if you have another kind of device somewhere on the planet for that person to use. Inference is latency dependent. Like the kind of trend we see with inference is getting it as close to the user as you possibly can, which a decentralized network could be effective for that because you can incentivize kind of like edge inference and things. You can incentivize people getting models close to the user, but its value is dependent on the size of the network, which is Metcalfe's law. Having Metcalfe's law be a bootstrapping problem for a blockchain network is a really horrible place to be because it essentially means you have to bootstrap the entire network before you realize the value of that network. It's things like Helium had this exact problem when they were doing their first use case, and it means you have to pour incentives into the supply side with the hope that the demand side will just pick up within the time window you have to create incentives. A horrible place to be. If you can bootstrap the network some other way, if there's another use for the network, i.e. a CDN, and then you can swap in the inference, that could potentially work, but that's the way we see that market going. So centralized CDN providers are in a much better position to create an inference network than somebody who's trying to build one from scratch. Whereas training, if you have a single device somewhere in the world, that's useful to somebody. Somebody can send a model over and have it trained. That's a kind of good value transaction. And then as you increase the number of devices, that value obviously goes up, but it's a more linear relationship than the other one. So that's the kind of backwards looking way. The forwards looking way is saying, well, training and inference in our view are just going to merge. If you look at the way, and this is kind of another analogy to the internet is this huge shared knowledge base that emerged over our ability to communicate between devices from those early standards that we mentioned before. The intelligence revolution that we're going through right now, in many ways, just represents a richer interaction with that knowledge base. It gives us ways to do it that we couldn't do before. We can distill information into it much more effectively because models can compress images and text and audio and everything into this shared embedding space. That's really exciting. But in order to interact with that big shared knowledge base, you have to go via models. And we think essentially we're in the kind of early internet there's just a single server and I'm reading information from it kind of phase right now, where it feels like the read activity is the most important one. But very quickly that gave way to us creating content on the internet as well. So when we started with client server, I just read websites and that's it, and then moved to, social media, now I'm creating the content and I'm updating it constantly. We see the same thing happening with machine learning, where inference is the read, but we also have create and update and delete, and those things will need to exist. And arguably they will overtake the read portion because we'll be creating that shared knowledge base together. We'll just do it via machines rather than directly. And that's why you need this protocol to allow the machines to do it on our behalf.
For any startup, it's important to think deeply about who your first best customer is. And I think, particularly in a market that is as new, as fast moving, as complicated as what you guys are doing, where there's lots of big players and a ton of centralized startups who all want a piece of it. Talk about what that customer looks like for Gensyn and how you came to realize that was a place to start.
I'd say there's kind of two points to this. So the first is just as a preliminary, the customer that we don't want are the kind of liquidity mining people who kind of come into networks and they sort of try and suck value out of them. We see that with some AI protocols just now. In terms of the ideal customer, it would be someone who's a machine learning engineer or who's training sort of 7 billion and up models, who is cash constrained, number one, or scale constrained. So either they want to train larger models, which they can't currently afford to train because just economically unable to, or they're like I was in my previous role, they're scale constrained. This maps typically to very early stage startups where either they're trying to do one of two things. So the key use cases, they're either trying to fine tune models for a certain use case so that they can include it in their product and they're constrained on price, or they're trying to build or pre-train larger models with new kind of decentralized architectures, but they're unable to get the scale required. On the second point, we do a lot of work in the kind of model architecture space itself to work out how you can retrofit larger model architectures in such a way that they work across decentralized hardware. Our thesis is that basically you can take models and by doing asynchronous training and sharding across lots of devices, you can beat state-of-the-art results, provided that the unit economic cost of the device is sufficiently low, because that means you can just run it for longer, you can get more of them. So yeah, it's succinctly machine learning engineers who are either skill constrained or cost constrained, and who are typically in sort of very early stage kind of seed startups.
I just emphasize a point that Harry made around the liquidity mining users. A similar kind of vein, an anti-pattern for an early user is somebody who is highly ideologically aligned with what you're doing, but not necessarily actually value aligned. You see this a lot in crypto projects where getting crypto native users is much easier. So you think, hey, I'll go after those users first because they're the easiest to acquire, and then I'll kind of expand out from there. But there's a classic trap there where you end up building a product for those users, and those users don't necessarily actually care about the thing that your product does. They care about the fact that it exists, and the signals they will give you won't be the same signals that you'll get from the real customers. So in our example, we could go to people within the Web3 ecosystem who do a bit of machine learning, and we could say, hey, you can do machine learning in a decentralized way now, but the signals they'll give us won't necessarily help us going to pure Web2 ML users and saying, hey, we've got something valuable for you now, because they see the kind of decentralization aspects and like, I don't care about that. What I care about is the price, or what I care about is the scale I'm able to achieve. So we take a kind of difficult decision to say, even though those users are much more accessible, we can't index to them. We have to find the more typical representative users of our larger kind of group. You can get them as well, but focus on the users that you expect to have in the future and you actually want to capture, because they'll be the people whose feedback you use to grow your product.
It puts us at the relatively gnarly intersection of Web 2 and Web 3, where there are people in the machine learning world, which Ben and I used to inhabit because we come from Web 2, who are completely crypto phobic. Like, they think about it and they just think of like SPF or like Lamborghinis and like monkeys.
Monkey
And like it's just like It's a changing thing from like the front lines of, machine learning research conferences, for example. There's increasing kind of development of decentralized training frameworks. So DePaco from DeepMind a few weeks ago was like the most recent kind of step forward in that direction. So there is this kind of emergent sort of, it doesn't use the word crypto, but for all intents and purposes, it's so aligned as to be, hand in glove of decentralized machine learning. So it is changing, but yeah, it's definitely a much harder sell. And this is doubly true for hiring as well, like trying to hire people out of these, Web2 machine learning shops into Gensyn. You have to almost teach them about like tokenomics and stuff like that, which is not an enviable position to be in.
And actually, perfect segue into what I wanted to talk about next, which is, and you can hear this in both your answers, but you guys have like a very unique way of organizing and running the company, right? So you're about 15 people total today. If I'm remembering correctly, nobody officially reports to either one of you. You truly co-lead and co-run the company, and there's no other people managers in the company other than the two of you. Talk about, I think one, how's it going? Why did you choose to go that way, and how's it changing as you continue to scale?
I think it's based ultimately on the principles that we share, like the place that we started, like Harry mentioned, that kind of like individual liberty piece. But then with that comes a few things, and we've codified those within Gensyn into 3 areas of autonomy, focus, and rejection of mediocrity. And those are kind of like nice snippets of describing the 3 buckets, but we spent a lot of time thinking about what they actually were. But ultimately it's this drive to empower the individual as much as possible. And that's the way we've always operated. So like you said, we don't kind of split our roles. We don't explicitly say that one of us does one thing and the other doesn't do that thing. We prefer the sort of emergent coordination that comes from just us having constant, robust feedback between the two of us and being able to navigate situations in that way. And it's worked fantastically well for us as a co-founding team. I think it wouldn't work for everyone. It only works particularly because we have such similar backgrounds and such similar skill sets. We've both done highly technical things, highly commercial things. We can both essentially sit at any point in the business and trust each other to be able to just navigate that and deal with it in a similar way to what the other person would. And we've broadly up to now kind of extrapolated that out over the business and said, okay, we will expect that to work in exactly the same way as we expand the team and as everything grows. When you do that, though, there are certain things that don't work at larger scale that would work between 2 people. And there are also certain things that we realize that maybe that works for us, but maybe that's not a kind of universal guarantee. It works for us in a more unique way than we'd maybe expected. So we're going through this process now of thinking about how do we stay true to those principles, but also allow the team to grow and don't kind of hamper it with uncertainty, because there could be a lot of uncertainty in the way that we operate. Like we don't have those rigid structures. We're okay with that, but maybe not everybody is. And maybe when you have 15 people instead of just 2, that's even harder to navigate. So it's something we're going through at the moment. We are bringing in a bit more structure, and we're thinking a lot, like the 2 of us and with the team, about what that structure should look like and which gaps we need to fill staying true to our principles and which ones actually the emergence of those is acceptable. It does work. And I think just being very deliberate about that should allow us and allow any company who's doing it to experience the benefits of that kind of free, open way of working where anybody can just kind of take control of something and drive it forward. It doesn't have to be that one person that you put in that position, because that's a very fragile way of working. If you didn't pick that person right, you're a bit screwed at that point because everybody else has just left it to them. Whereas that if you let people figure that out themselves, you end up with, if you go too far, I guess a bit Darwinian, but you end up with the kind of best idea wins sort of environment. And we think very early for a company, that's far more performant than having that rigid structure, but it definitely changes through time. I don't know if you'd modify any of that, and maybe it'd be good to talk a bit about the structure we're talking about.
Where the rubber hits the roads in the engineering team. Basically, we have obviously like a highly technical product. It broadly quarters into compiler design and engineering, distributed machine learning, the like blockchain specific architecture of the node, and then what we're doing on the verification side, so the cryptography. those four things are, they're not like orthogonal to each other, but they're quite distinct. For someone to kind of emerge in that team with enough context over each area and also have the requisite, ability to be a world-class IC in that area, and to also be a engineering leader, and to share the vision, and to kind of you just keep adding these things on, and eventually there's nobody in the fucking world who can do this. So we made the decision to bring in a VP of engineering, with the idea that that person has not necessarily a kind of hierarchical command and control style relationship to the team, but they have a very explicit mandate in a way that other people don't. So typically when we hire people, don't really care about titles that much. We'll just, hired as a distributed systems engineer. Theoretically, you could work anywhere in there and you're incentivized to. But for this person, it's relatively static. So you will focus on, making sure that the team performance is high, making sure that everybody's coordinated, and helping kind of compress a lot of the vision that we've talked about today into the engineering team such that it's aligned with the both of us. And that's been a big step for us because it's the first kind of middle-ish explicit layer that's been put into the company. And it's a bit of a departure from the kind of heady days of that we had previously.
So last question, and then we'll open it up for questions. But so one thing that I see a lot on our calls, and that's always impressed me, is that there are many times when there's a company critical issue that you're both wrestling with. You don't always, at least at the outset, both have the same perspective or agree on either what the issue is or the right path forward. But through deep questioning and conversation, you're able to often form a perspective that actually is almost never where either one of you started, but is like a fusion of both of your best ideas. Talk about, was that something that has always been part of your relationship from day one? Was it something you had to work on together? Like, how did that come to exist? Because I think it's quite powerful and you don't see it that often.
I think it's both of those things. It's always been there from day one, but it is something we have to constantly work to maintain. At the end of the day, I think it's down to a absolutely kind of like unwavering belief in the incentive alignment between the two of us. Like, I 100% trust that Harry's incentives are to grow Gensyn, as are mine. And so it's kind of like from both of our sides, we think, I might have this position that's not necessarily correct. Harry has this different position. The outcome of the merging of those two positions will be the optimal for Gensyn. So we're then willing to put in enormous amounts of kind of effort to make sure we get to that outcome, rather than breaking it and saying, okay, we'll do that thing, but actually I think it should be the other thing. We root out the definite kind of end state shared position because it should be the best one. I think in some ways it is expensive. Like, it's expensive on our time, and it's something we've realized when we were in person together. We had an office for about a year before we gave it up and went back fully remote again. And we spent loads of time in that office just talking together about issues we were facing, but also philosophical issues, because it let us figure out where we both stand on certain things and to understand the other's position and the likely position in the future. As we then went remote again, we had to figure out how to still have that. And that's been something that we continually work on. How do we make sure the atomic information flow between the two of us is as high as it can possibly be in order to keep that communication kind of channel open and allow us to make those collective decisions? The end state of it, I think at least, is that we now have this ability to act independently in the vast majority of situations and trust the other to make a decision that is aligned with the center. And then in those mission critical situations that you mentioned, Jason, we come together and we can very quickly now, maybe not earlier on, get to the shared position and move forward. So it allows us to be very independent, but also act together as and when we need to. And each person has an idea of when that is. So we'll know, hey, in most situations, in this situation, I can just act. It'll be aligned with Harry. That's fine. But in this situation, actually, I know he's going to have a different position. I don't know exactly what that's going to be, but I don't want to just act on my position. I want to act on our shared position because I think that'll be optimal. So that's the way I view it. It's down to that incentive alignment, I think.
I totally agree. I just actually give one bit of tactical advice, which is advice you gave us, because we're in very different time zones. So Ben's California based, I'm London based. We basically bookend the whole company because we're split between the US and Europe, which I would actually recommend. Just like generally, if you're hiring a founder at either end, it means that the center of gravity doesn't shift to where the founders are. But obviously the time zones are ridiculous. So we have a shared private Slack channel, which we only put the kind of, I guess, well, we have two actually. We have one where we only put the kind of mission critical things. So, if there's some big decision which is coming up or some state that we want to push to the other person, we put it in there. We have a separate one for team as well. So when we do the kind of one-to-ones of a team, or if we're seeing any performance issues, we put that in there. And the consequence of that is basically our normal channel can be kind of fun and games and kind of keep the sort of banter and everything going without having to drop a kind of nuclear warhead in the middle of it every sort of hour. So yeah, that's just a good tactical thing if you find yourself working in a very asynchronous way.
I think the state update piece is probably quite interesting to people as well, because we explicitly have different ways of communicating between the two of us, where every so often we will explicitly communicate, this is a state update for me. I'm going to tell you some information. I'm going to tell you that I have changed my internal position on this. Because a lot of the time you'll be telling somebody information and that person will listen to it and they'll think, okay, sure, some external inputs come in, but I don't know where you stand on it. And a lot of time you actually haven't changed your position. You're just saying, hey, there's more external information, you need to know about it. But now we're very, very explicit where there's been some external information and explicitly, I used to be here and I am now here. And so that lets us in the future situations that might coincide with that to think, okay, I know Harry changed his position on that, I have to talk to him, where before, knowing his position, I'd be like, okay, I can just act. So we kind of very explicitly have this separation of, this is a state update versus this is just some new information that you probably need to know, but take it however you need to.
Fantastic, good advice. All right, well, with that, let's open it up to the room.
How do you feel about economies of scale? So someone with a single GPU at home might not achieve the same efficiency or power consumption cost as a large center which hosts a bunch of GPUs. And that's kind of similar in spirit to how Satoshi was imagining the original one CPU, one vote, right? I guess the mission is a little different because the mission that I assume your mission is not one GPU, one vote, but rather decentralizing and permissionless training. But that, if you take this, sort of extrapolate this could sort of lead to concentration of power because these large centers can actually outcompete the individual players, right? So you actually end up with more centralized solutions.
Yeah, I'd say kind of there's a macro and a micro response to that. The macro is that's the default already, in Web 2, right? So OpenAI is that thing, and it can't be worse than that. So it's always a step back. But more practically on the micro level, I think there always will be kind of Pareto style relationships to things in decentralized networks. But I would say that because the network is permissionless, the idea is that at least not at the kind of staking level, which I guess is a different question, but at the actual market order level, if you're trying to, purchase flops on a device, you're able to just do that with anybody on the network, which keeps it open, it keeps it free, it keeps it kind of liberated. I also think that there's an argument that when the scaling continues into kind of GPT-5 and everything keeps going up an order of magnitude, both at the data level and at the compute level, there will be even more demand for people to train very large decentralized models, which in turn will make an individual with kind of a GPU more economically important. So the idea there is that basically there'll be more and more demand for solutions like this. They'll increasingly need to be more and more decentralized and activate the long tail. So there's a kind of a push in that direction coming from just the economics of model training.
We're not kind of in pursuit of a perfect solution. It's not like we're trying to present something that perfectly solves all these problems. I think the idea from our side is the current system is skewed for lots of reasons that aren't necessarily emergent from a free kind of market. They're reasons that people have created for themselves in order to have pockets that kind of control power and ability within that market. We'd like to move to a system that is much, much more accessible and much more free. The emergent system from that, like you said, in some ways may be still constrained in terms of power. It may trend in that direction, but that's a much more natural direction than the current one that's been created specifically to have those power structures. So it's not saying that like creating a free market over this just is like a panacea. It's saying that creating a free market over this is inevitably better than the current situation that we have. On the economies of scale piece, and the kind of, if you look at what happened with like Bitcoin became this almost like energy efficiency mechanism for the planet. We'd like to see that happen for AI compute as well, where it does push the performance and the creation of these compute data centers to areas of lower electricity. Those will move around. People will see opportunities within that. If somebody can build some green, very cheap electricity source, then they'll be able to build a data center there, and they'll be able to actually kind of realize the benefits of that. Maybe that trends upwards, but it constantly changes. So every discover new things, it can change. Right now, it can't change. It's very, very difficult for somebody to come along and say, hey, I've got this super cheap source of electricity. I could build a data center here, but I have to become AWS before I can do that. So yes, it will end up in pockets, but those pockets will break and reemerge and reform. And it's this system that constantly evolves rather than just being stuck where it currently is.
I have more of an engineering side of question. So I used to work in machine learning, and from what I understand correctly, you need to run very specific models on via Gensyn, right? Because if I think of a very large model, I think you said latency is not important. But in my experience, latency was everything. Like as soon as I need to split the model over 100 GPUs, as soon as they're not communicating over NVLink, I wouldn't see how they could possibly train anything efficiently. So would I need to come up with specific model architectures that don't have communication on the batch level, or how does that work?
Yeah, in the current way of training models, that's true. We see two solutions to that, and we work on both of them. So it's not like we're saying, hey, yeah, you have to come and build an entirely new model. We're designing the protocol to be more performant for those situations, but it'll be a bit of both. There will also be drive from the ecosystem to build new models for this. The two different ways are, one, just treating the Gensyn network as a big problem to optimize when you have an existing model. So you have this model which currently operates over 50,000 GPUs, say, and it needs those interconnects. It expects homogeneous latency, bandwidth, and devices. If you then throw that model over a network with heterogeneous latency, bandwidth, and devices, you create an optimization problem for yourself. So where are you moving the compute? Where are you doing more communication and more compute? That is just one big problem to solve. And we can do a lot of work in order to get closer to state of the art in doing that. You'll never get better than a centralized cluster, but you can get much closer than most people currently think. So that's a maybe shorter term approach because it takes those existing models and just optimizes them. The longer term approach is entirely new model architectures in our view. But if you look at the way the architectures as we currently have progressed, they've not been built for very long. Like we've not been doing these like distributed training runs for very many years. It's not necessarily the only way to do it, but I think the machine learning space gets this like really short memory where it thinks that just because we've had success there, that's the only way to do it and we should just continue down that path. Actually, we're seeing the scaling limits of physical data centers now, not from a cost perspective, but from a geographical perspective. Like how can you build a bigger data center somewhere on the planet that you can cool, that you can put 100,000 or like 1 million GPUs in? That becomes a problem that's insurmountable at some point. And so we say, instead of increasing that arms race and carrying on trying to build bigger data centers, let's shortcut it and say, hey, you now have access to every single compute device in the world, but yes, it's heterogeneous latency and bandwidth, so we'll have to think of a new way of building models between it. But we're more bullish on that than just continuing down this path of trying to build a bigger data center.
If you want to read more about that, DeLoco, DePaco, Varuna, and Alpa research papers cover the variations of optimizing for that problem.
I'm Tim. I'm also building an AI-aligned protocol, not competition for you guys, don't worry. So one thing I really love about the Light paper is that you took 3 really important research pillars and you managed to actualize those, like probabilistic proof of learning and the true bit incentive system. And we've had lots of discussions about incentive alignment and game theory here. I would just like to know, like, so I can follow in these footsteps, the concrete steps you took from, I have some cool academic papers that can inform my protocol. What did you do? Who did you talk to? What were the steps you took to turn that into the actual?
I guess to start at the very kind of like beginning with pre-Light paper, we discovered that solution when looking specifically for a solution to the trust problem. We weren't in the crypto space. We were completely outside of it. We were doing verifiable computation, kind of like literature review, essentially. And as we did that, as we came to solve that problem, we put those solutions together. But it was purely in service of solving that problem, which I think is the kind of purest way of doing it, essentially. But yeah, that was the kind of construction of the light paper. After that, it was figuring out what do we need to do on each of these pieces, like where are the, and there's a principle here that maybe we're giving it away from Entrepreneur First that they have, which is run into the spikes. And that's the idea that when you have an idea or a business idea, whatever, you have a thing that you want to create, there'll be something in that thing that worries you the most. There'll be a part of it that you're like, if this is going to fail, it's going to fail for that reason. And the run into the spikes principle is like run directly at that thing. Don't think about the things that you're like excited about. Think about the things that worry you and go after them. And that's what we did with the light paper. So one of the things we discovered quite quickly is that proof of learning is actually flawed. It doesn't work in practice. It's flawed unless you add cryptography. And that was something that we were uncomfortable about. We talked to the authors about it. We talked to other people in the kind of research space about it because it was this spike for us. And in doing that, discovered, hey, here's some solutions within cryptography. We then chased those down and ended up at the interactive proof system that we have now, which sits alongside it. So it's just been this constant process of saying, okay, we're happy with this light paper construction, but there's a few spikes on it. Let's go directly at them. And it's how we operate now. It's every single kind of decision we make is basically driven by a kind of consideration in our minds of is this likely to be a limitation for us? Is this likely going to be the reason why this thing fails? If it is, let's find out immediately, and then we can go in a different direction, or let's smoke it out so that it's not actually real. So yeah, I think it's been that process of just running at spikes continually.
I'd add like one point, which just be willing to make reasonable assumptions as well. Like one of the things which we struggled with maybe 2 years ago was the idea that, if you don't model people as financially rational, everything doesn't work. If someone's just willing to like spend infinite sums of money to like break a protocol, or if it's like like the US government or like the CCP just want to crack like Bitcoin, and buy up all the ASICs and stuff. There are ways to like, fork it and stuff and kind of solve against it. But, you have to at some point just make assumptions. We had something or we still do in our internal literature called like Big G, which is just like a government attack basically, where, if you're modeling something endogenously in game theory and you're like, well, the staking kind of requirement versus the probability of being caught multiplied by the slashing, effect is such that there's, negative expected value to cheating. But what if someone paid them $1 trillion? Like, you just have to like at some point constrain the problem. And I think that that's a trap that some of the best people that we've met in the space have fallen into when we tried to hire them, and they've just been lost in this world of how do I make it perfect.
If you think that OpenAI is asking for 7 billion for hardware acceleration, and doing that with an open source model, decentralized way, and giving data ownership to the user is so valuable. So my question is how you are planning to incentivize user which running model to contribute decentralized AI?
It's so essentially, why would someone use us? Economics is the bottom line. There are two reasons that our solution is cheaper. The first is it removes this 80% margin that Azure, GCP, etc. charge on their on-demand instances. Nobody pays that margin. It's always a bit lower, but at the end of the day, it's significantly cheaper, point one. And then point two, by activating this long tail of supply, you typically have a deflationary effect on the price in general. There's also the point as well that just the kind of there's like an arbitrage between, say an A100 40 gigabyte and 2 RTXs for training. If you do like a fully sharded data parallel Mistral 7B fine tuning run with LoRa, we've done these tests internally. It works out significantly cheaper doing it on the RTXs when you consider the kind of asymmetry in prices. So there's just this kind of economic reason and scale reason. I think that's certainly on the demand side. On the supply side, it's a little bit trickier. There's definitely, we talked to kind of mining teams from like the big players like Foundry, etc., down to the kind of smaller people who run like a shipping container full of RTXs in Serbia where there's like cheap power and stuff. And it's our thesis that with the demand that we can bring from the unit economics, it will pay for people.
Some bootstrapping of the network saying, hey, the network itself, the protocol itself needs to incentivize participants. Some of that is useful, but it's useful in a very like contextual way. It's not useful if just applied in a blanket way to say, hey, the protocol pays people to put GPUs on and at some point it won't anymore and the demand side will cover it. You can't definitely build a viable network in that way. If you know that you need to bootstrap for a very short period of time, then you can use it sparingly. But our view is that the incentive system should be as simple as possible, and it should be as close as possible to somebody has a need and somebody else has something that they can provide, and you connect those two people together, and the protocol should be minimally involved as possible in that transaction. But there's a lot of talk about these complex incentive designs. I think as soon as it starts getting complex, you're probably actually creating more of a problem for yourself than you're actually solving one. So go back to basics and just say, hey, am I solving that user need? If I am, it's probably in the right direction.
Hey guys, really love the parallel that you guys drew between essentially AI as you see it currently in the early web, with like their reading, writing, and I guess owning, and the comparison between reading and that being like inference for ML, and eventually models being able to write. And if you kind of continue that parallel on, do you see the models being able to own as well?
Yes. We think what we're going through, you can view the kind of progression of machine learning models in a similar way that you view autonomous agents within like the research space. When somebody creates an autonomous agent right now in a pure research context, they create an environment for that agent, and then they create the ability for that agent to interact with that environment. What we're creating with initially starting just with the crypto space in general is an increasing sized environment that agents can actually interact with. So with smart contracts, we can create financial agents now. They can act in exactly the same way we can in that constrained environment. We view Gensyn as giving them the crucial access to their own resources to continue to exist, and that's an increase in size of their environment. But that environment's going to continue increasing in size. And at some point, humanity will go through this kind of weird process where we say, wow, these agents are kind of equivalent to us in a lot of places now, and we're going to have to go through a general sort of social governance discussion of like, at what point are they human? Because they have almost as many rights and abilities as we do, and it's exciting.
I suppose you've got the verifiable computation to be able to ensure that it's actually from the model, right? In a decentralized, trustless way.
Yeah, I mean, that's a crucial part. Yeah, if you think about that agent in the future, how can we kind of know what we're interacting with? The provenance flowing through for the agent, it creates the trust where humans would have different trust structures. Maybe we've got like attestation from a university or something that shows that we know something. Agents will need to have those similar things, and we can build those with technology, but it's not like we're trying to recreate what exists for humans. We're trying to create what should exist for them in a way that works for them. So it's parallel, and there will be constant parallels, but it's not trying to recreate what works for humans. It's trying to just increase their agency in their environment.
Thank you all. Thank you, guys.